Hi everyone, welcome to week 12, the final week of our Smart City course. Over the past 11 weeks, we have explored how cities are being reimagined through technology. Today, we will bring everything together and look at the frontier, the technologies that are shaping the future of urban life right now. So let us define it properly before we go any further. So artificial intelligence or AI is the simulation of human-like intelligence by machine, particularly computer system. In context of smart cities, the AI refers to a software system that can collect data, identify patterns, can make predictions and take actions. Often this happens in real time and at a scale no human team could match. Now the global AI market is projected to reach 158 billion US dollars by the end of year 2030. That is not a technology bubble. That is a fundamental shift in how these cities, governments, businesses and services operates. Approximately 35% of the cities worldwide were already using some of the AI by year 2025. So it is not a theoretical future which we are predicting, but it is the present. Think of the AI as working through a three-step value chain, where first step is data. This includes the raw, unprocessed information from different IoT sensors, cameras, citizens, etc. The second, we have insight. The AI algorithm process the data obtained and find patterns which will be normally invisible from the human eyes. And third will be action. The system acts on those insights automatically or by advising a human decision maker. The cities apply AI across four major domains, which include the mobility. This includes the traffic optimization, etc. Then safety, which includes the crime prediction. Then on infrastructure front, which includes the predictive maintenance of water pipes, power lines, roads, etc. And on the service front, which includes the citizen engagement through chatbots and virtual assistant. We will cover each of these in detail in today's lecture. Before we look at applications, we need to understand the four core technologies that power urban AIs. Think of them as the four engines of aircraft, and all these engines should work together. Let's first see the machine learning. The machine learning is a branch of AI where a system learns from historical data to identify patterns and make predictions without being explicitly programmed for every scenario. The more data the system sees, the smarter it gets. In urban settings, the machine learning powers demand forecasting, predicting how many buses will be needed on a route next Tuesday morning. It powers any kind of defect detection, spotting that a particular water pipes or the electricity line is behaving unusually, possibly because it is about to crack or about to fail. It powers the resource optimization, deciding which zone needs more garbage trucks today based on the yesterday's data. Next we have computer vision. The computer vision is an AI field that enables machines to interpret and understand visual information from the world, images, videos, and live camera fields. This will happen in the same way human uses their eyes and brain to see these data together. In cities, computer vision analyzes footage from traffic cameras to count vehicles, detect any kind of accidents, or identify the wrong way drivers. It powers facial recognitions at airport, for example, DigiYatra app. It monitors crowd density in public spaces, triggering alert if density crosses certain threshold, which is critically important for events like Kumbh Mela in India or a New Year celebration in major cities. Then we have predictive analytics. This predictive analytics uses statistical algorithm and machine learning to forecast the events based on the historical and current data. The goal is to answer what is likely to happen next and when. Then we have natural language processing, NLP. This is the branch of AI that enables machine to understand, interpret, and generate human language, both in written and spoken. It powers chatbots, virtual assistants, voice search, and automated translations. In Smart City, this NLP powers the chatbots on government portals that answer citizen queries at any time of the day. It powers sentiment analysis, reading thousands of social media posts and citizen feedback forms to detect emerging complaints before they actually becomes a crisis. Now here the key insight, and I want you to remember this, these four technologies do not work in isolations. In real smart city platform integrates all of them simultaneously. Machine learning model process data from computer vision system, predictive analytics forecast outcome, NLP communicates results back to citizen and staff. Integration is the real challenge and the real opportunity also at the same time. Let us now move to most visible applications of urban AI, which is on the traffic management. I want you to think about a traffic junction in your city. How many of you have sat at a red light while the crossing road is completely empty? That is a dumb signal, a fixed timer signal with no intelligence. What we are talking about today is exactly the opposite of it. The AI traffic management works through these stages. Let me walk you through each of this. The stage 1 will be the collection of data. The sensors embedded on the road surfaces, cameras mounted on the signal poles, GPS data from the connected vehicles and mobile apps. All of these feeds real-time information about the traffic flow, the speed, the conjunctions into the central system. This is your eye and this is the data layer. Next stage we have is pattern analysis. The machine learning model continuously analyzes this data. They have been trained on years of historical data, morning peaks, the festival days, monsoon slowdowns, school holidays. They know that on a Tuesday morning at 8:15 a.m., the ring road will begin to congest near the commercial zone. They know this because they have seen it happen thousands of times before. The stage 3 is prediction and optimization. The AI forecasts consumption 15 to 30 minutes ahead of time and it immediately adjusts the signal timing. In real time, the green phase is extended on the congested road, the red phase is shortened when the road is empty. Emergency vehicles approaching an intersection trigger automatic green light clearance. Adaptive signals responds to a real-time conditions, reducing wait times and improving traffic flow continuously. If we see the stats, the travel time due to this can reduce to 25%, the emissions can reduce by 40%, the wait time can reduce up to 30%, and accidents can be reduced by 20%. Let's try to understand this from some global case studies. First example is from Hangzhou, China. This is one of the most ambitious urban AI deployment in the world. The AI-powered traffic management reduced emergency response time from 18 minutes down to 11 minutes, a nearly 39% improvement. When a city gets your ambulance to you 7 minutes faster, that difference can mean that somebody will survive. Next example is from Los Angeles, USA. Their ATSAC system, automatic traffic surveillance and control, manages over 4,500 intersections across the city. This is the largest such system in North America. It uses centralized control with AI-driven adaptive timings. Next, we have the case study of Dubai, UAE. The smart traffic system platform integrates signals, cameras, and sensor across the entire Emirates. The Dubai is an excellent reference for India because it is rapidly urbanizing, high density city with a similar infrastructure challenge. Finally, and I find this one particularly meaningful for you, Dubuque city in Iowa state, a small American city of roughly 60,000 population, they successfully deployed AI traffic management. Now, why this matter? Because it proves that the technology is scaled down. You do not need to be a Mumbai or Beijing to get benefit from AI traffic management. A mid-tier Indian cities like Indore or Bhopal can also implement such systems. The key lesson from all four cities is benefit appears within weeks of deployment, but full optimization can take months. As the AI learner, the seasonal and local pattern specific to your cities would be developed over the time. Now let's talk about AI in public safety. This is the domain with extraordinary potential and extraordinary ethical responsibility. I want us to hold both of these truths at once throughout this discussion. AI enhances public safety through three primary mechanisms. The one is the predictive policing. The AI analyzes historical crime data, type of crime, location, times, day of week, weather, and events. This is to identify pattern and allocate police resources proactively. If the model predicts that a particular market area has elevated robbery risk, on Saturday evening during the summer, the police department can increase the patrolling in that area for that time period. The second is the emergency response optimization. The AI analyzes real-time traffic, road closure, and incident data to compute the fastest route available for every emergency vehicle. It predicts incident severity based on the nature of emergency call. This is a minor fender bender or a serious pileup requiring multiple units of support. The AI decides the resource allocation automatically. And third is about the crowd management. The computer vision system monitor crowd density in real-time basis at public spaces, railway stations, markets, sport stadiums, religious gathering, etc. And they detect any kind of defects. A crowd suddenly moving in one direction, a gap forming, etc. can be identified using this. This can indicate any kind of panic or rush developing in the crowd. An early detection here can save multiple lives. Now next, let's try to understand the impact matrix of this predictive policing. This can reduce the crime by 15 to 20%. This can reduce the response time by 30%, and it can reduce the risk of false alarm by 40% and increase the resolutions of cases by 50%. But in this predictive policing, there is an angle of ethical concern. This predictive policing algorithm trained on historical data can populate and amplify the systematic biasness. If certain communities were historically over-policed, the data will reflect the same, and the algorithm will recommend even more policing for those communities. This is called algorithm bias, and it is one of the most serious ethical challenge while implementing urban AI. Now let us talk about the something that affects every city, the infrastructure maintenance. The traditional approach is reactive approach. Wait for the pipe to burst in a water distribution system, then fix it. Or schedule replace the pipe every 20 years regardless of its actual condition. Both approaches are inefficient and expensive. AI enables a complete different approach which is based on the preventive maintenance. The preventive maintenance here is an AI-driven approach where IoT sensors continuously monitor the performance of the infrastructure component like pipes, transformer, road surfaces, your HVAC systems. And machine learning algorithm detects suitable patterns that indicate depending what kind of failure is going to happen. This allows the repair to be scheduled before the actual failure occurs. The process has 4 different steps. The first step is the sensors deployment. The IoT sensors are embedded in or attached to an infrastructure component. For water pipes, the pressure sensors and flow meters. For electrical transformers, are temperature and vibration sensors. For HVAC systems, the energy consumptions and air quality sensors. The second step is data analysis. The machine learning model continuously processes the sensor data and compare readings against the historical baseline patterns. The model knows that the healthy pipe data will behave like what, and what a healthy transformer's temperature curves look like. The third step will be the failure prediction. The AI identifies the deviation, like this pump is vibrating 0.3% more than as usual. The pressure differentiation has increased over the past 7 or 2 hours and predicts the probability of failure within a given time window. The fourth step is the proactive maintenance, where maintenance crew are dispatched to replace or repair the component before it actually gets failed. The pipe gets fixed before the road floods. The transformer gets serviced before neighborhood loses power. This results around 30% reductions in the maintenance cost and around 50% reductions in power downtime. The fundamental shift is from reactive to proactive, from fixing problems to preventing them. For India specifically, where infrastructure failure can be very critical, a burst water main disables a road which delay an ambulance. This proactive approach has enormous and multiple benefit. This preventive maintenance applies across 3 major city systems. The water system, where AI detects leak through pressure and flow analysis. This can also predict the pipe degradations. Then for energy grids, where AI predicts the transformer failure in advance, and it can also forecast the energy demand to optimize the generation. And also on the front of building management, the AI can optimize the HVAC scheduling, detects lightning faults automatically. To more critical infrastructure applications like smart grid optimization and intelligent waste management. The smart grid optimization, here the AI optimizes energy generation, distribution and consumption in real time. This is increasingly critical as cities integrate renewable energy sources like solar and wind, which are not continuous. The sun does not always shine and wind does not always blow. The AI manages that balance, shorting the energy when supply exceeded, drawing from the store when demand exceeds. The demand response is the key application. The AI adjusts consumption pattern based on the grid condition. During a high demand event, it might automatically lower the temperature set point of any commercial buildings by 1 degree or 2 degree. Now this optimization can result in around 25% saving in energy, 30 to 50% saving in building energy, around 20% improvement in grid efficiency, and around 25% reduction in water losses through smart metering. Now intelligent waste management. This is extremely relevant for the Indian cities. Today, garbage trucks run on fixed routes, fixed schedules, regardless of whether bins are full or empty. The AI application changes this completely. The smart bin have fill label sensors that transmit real-time data. The AI calculates the most efficient collection route based on the actual fill labels. Only visiting full or nearly full bins can improve the efficiency, reduce the use of fuel, and also reduce the time to reach those bins. Now let us look at a citizen-facing side of urban AI. How does AI change the experience of interacting with your government? Today, if you need to renew a trade license in most of Indian cities, you go to an office, take a number, wait, speak to a clerk, then they will tell you that you filled a wrong form, go home, come back, wait again. This is the experience most Indians have. The AI can transform this scenario entirely. The AI-powered chatbot provide 24-hour, 7-day a weak responses to common citizens. This can also answer the query in multiple languages. What document do I need to apply for a building permit? Where is the nearest public health clinic? When is my garbage collection day? These questions, which currently requires a human staff member to answer, can be handled instantly and automatically by AI. Beyond answering queries, AI enables personalized recommendation. The system knows that you got recently married. It proactively suggests updating your ration cards and voter registration. You filed a water complaint 3 months ago. It follows up automatically about what is the feedback, what is the status of that complaint. It also automates the processing of handling certain permits, license and application. The document verification happens through the computer vision. The system reads what you have uploaded, cross-check with the government database and approves or flag for the human review. The process time here will drop from weeks to hours. This results from cities that have implemented AI citizen services. Around 70% citizen satisfaction has been improved. 60% cost reductions and 50% reduction in processing time and around 24/7 service availability. This also gives a multilingual support, and this is going to be a game changer for a country like India. A single AI system can communicate in Hindi, Marathi, Gujarati, Tamil, Telugu simultaneously, breaking down the language barriers that have excluded millions of citizens from accessing the government services. The other side of citizen services is listening. The traditional government feedback work through surveys and complaint forms, which is normally slow and have limited reach, and also the low response rate. The AI enable continuous and real-time listening. The sentiment analysis is how AI read the mood of a city. An NLP application that automatically classify the text, social media posts, reviews, survey response and complaint forms as positive, natural or negative, and identifies the topics being discussed. It allows the city government to understand citizen satisfaction at scale and in real time. The data source for sentiment analysis includes the social media post, maybe the post from Twitter, Facebook or WhatsApp group. Also the survey responses, the call center logs, the emails and feedback forms to understand the citizen satisfactions at the scale and in real time. The AI continuously scans all these sources, categorize each piece of feedback by the topic: road, water, garbage, public transport, healthcare, and track sentiments over the time. If frustration about the parking in a particular neighborhood spikes in the data, the city can investigate and respond within some days, not after the next municipal election. This is the transition from data to action. The most important data in urban AI, the value is not in collecting the data. It is in translating the data into the decision and action quickly. I have saved this section for the end of lecture 1, but I want to be clear. This is the most important section of the entire day. Every technological capabilities we have discussed is only as good as the governance and ethical framework surrounding it. There are 5 major ethical challenges in urban AI. The first is the algorithm bias. The AI system learns from the historical data. If the data reflect historical discrimination, the AI will pursue the same. A loan approval algorithm trained on the historical data can deny the loan to the certain communities. The solution here is there should be fairness in audits, there should be diverse data training, and there should be biasness testing. The second, we have transparency. Many AI systems, particularly deep learning neural networks, are what we call black boxes. They produce output but cannot explain why. A citizen denies a permit by an AI system, has a right to understand the reason. The solution here is to explainable AI, also called XAI, designing systems that can articulate their reasoning in human terms. The public documentation of how city AI system work, open algorithm, were possible. The third, we have data privacy. The AI requires massive amount of data about citizen. Every time that data is collected, stored or shared, there is a privacy risk. The principle of privacy by design means building privacy protections into system from the very beginning, not adding them just as afterthought when the incident or scandal occurs. The fourth is the job displacement. Automation eliminates jobs. This is the real refuse collectors, data entry clerks, parking enforcement officers. These jobs are at risk. The government have responsibility to fund reskilling program, support job translation, and explore new employment model. The technology that improves a city but destroy livelihoods without any safety is not a smart governance. The fifth, we have accountability. When an AI system makes a mistake, and it will do, who is going to be responsible? If an autonomous vehicle controlled by the city system injures a pedestrian, who is going to pay? The city, the algorithm developer, or the manufacturer? The clear accountability framework, liability chain, human oversight requirement, appeal process must exist before the systems are deployed, not invented after incident has occurred. So that's it for this module, this lecture. Thank you.